Hello, person who is currently watching and grading my project. So let's get started on Project 4 Measuring Motions, which is by me, Madeline Jones. So for my project, I measured the motions of the first two actions of my Rube Goldberg machine. So as you can take a look to the right, we have a person using a Rube Goldberg machine. This is not my Rube Goldberg machine. If you want to look at my Rube Goldberg machine, go back to Project 3 on my webpage. And let's look at Action 1. So Action 1 utilized tension force. What happened was the stop sign snaps forward after the rubber band is stretched by the ship's wheel. So what happens is this ship's wheel is turned by a person, and then it hits this knob, hits this, which causes that to stretch back in this direction, and then when the lever lets go of that, it causes it to spring forward because of the rubber band and the tension force in here. So here is the motion map for the project. Here is the data tables for the parallel version of Action 1. And here's the data tables for the perpendicular versions of Action 1. Yeah. And so, yeah. Alright, so here's the position time graph for the perpendicular Action 1. Here's the position velocity time graph for the parallel Action 1. Here's the velocity time graph for perpendicular Action 1. And yes, it's quite amazing. So here's the acceleration chart for the parallel graph. And so my acceleration is negative 8.767 times 10 to the negative 3 meters per second squared. And then my acceleration for the perpendicular graph is 8.868 times 10 to the negative 3 squared and meters per second squared. So the description is the stoplight moves in a positive direction for 0.8 meters, then it snips back in a negative direction with the acceleration of negative 8.767. You already saw the already read aloud the acceleration, and at that velocity, and at the perpendicular motion, the stoplight moves in a negative direction for 0.8 meters, then it snaps forward in a positive direction with this acceleration and an average velocity of this. So action number 2 utilizes gravitational force. So this rubber band ball, after it gets hit by the stoplight, it rolls down this ramp and hits this cup and activates the pulley. So here's the motion map of the rubber band ball. Goes there, nothing super special. Here is the data tables for the parallel part of Action 2. And here are the data tables for the perpendicular part of Action 2. Alright, here's the position timed graph for Action 2 in the parallel part. Here's the perpendicular position time graph for Action 2. Here is the velocity time graph for Action 2 when it's parallel. And here's the velocity time graph for when it's perpendicular. Here's its acceleration. So its acceleration is negative 0.02439 meters per second squared. Then the acceleration when it's perpendicular is 0.0439 meters per second squared. So it's like the other one, except it's positive. So the description is the rubber band ball rolls down the hill into the cup in a negative direction, accelerating at a rate of negative 0.02439 meters per second squared, with an average velocity of negative 0.22 meters per second. So then for the perpendicular, the rubber band ball rolls down a hill into the cup in a positive direction, accelerated at a rate of 0.02439 meters per second squared, with an average velocity of 0.22 meters per second. So this one's negative, positive, negative, positive. And that is the end of my project. I hope you have a good day or a night, depending on when you're watching this. And bye.